Good day, everyone. My name is Chen Chong. I'm a Specialist Solutions Engineer from the Virtual Cloud Networking Sales Team at VMware Singapore. In this demo, I'm going to show you how you can use NSX Advanced Load Balancer or AVI networks to provide GSLB as well as ingress controller functionality for a cross data center Kubernetes deployment. As you can see inside this diagram, I have two data centers that are being simulated in a lab environment. All right. In data center 1, I have the vCenter that is managing the workloads across both data center 1 as well as data center 2. And in data center 1, I also have the NSX Advanced Load Balancer controller, or what is typically called the AVI controller, that is managing the AVI service engines, right, in data center 1. And I also have another AVI controller, right, that is managing the AVI service engines in data center 2. The Kubernetes environment that is being used inside this demo is based on VMware TKG, right? In data center 1, I have a TKG cluster that comprises of a single master and a single worker node. And similarly, in data center 2, I have a TKG cluster that comprises of a single master and a single worker node. Now, with NSX Advanced Load Balancer, we now have the capability to use AVI Kubernetes Operator as well as AVI Multi-Cluster Kubernetes Operator to provide ingress controller and GSLB functionality for container pods that are deployed in a cross-cluster deployment like this. So in this example, right, for the TKG cluster 1 in data center 1, it will be installed with the AKO, right, which runs with as a pod, right, within the Kubernetes deployment. And because data center 1 is also the GSLB leader, right, it will also be installed with the AMKO, which again, right, runs as a pod within the Kubernetes environment itself. Now, for data center 2, right, it is the GSLB follower, and hence, right, it only has got the AKO installed and running as a pod itself. Okay, so and within this environment, I will demonstrate that I have a web client that is accessing services, right, that are created across both of these data centers and running on Kubernetes pods, right, and I will have the AVI GSLB component that is providing the load balancing across both data centers. Okay, so let's take a look at how this is actually being set up from the CLI perspective. So over here, right, I have two TKG clusters, as I mentioned. So on my TKG jump host, right, I run a TKG get clusters. I have cluster 1 and cluster 2. All right, so let me just switch to the correct context over here. Let's say if I'm going to the first cluster, TKG get credentials, my cluster 1. Okay, so then basically, right, I will log on into the first cluster. Just to make sure that I'm on the right cluster itself. So this is the master as well as the worker node in TKG cluster 1. And let's check what is it that is running within this environment itself. So as you can see, right, as I've mentioned, right, I have the AKO, right, which is running as a pod in the AVI system namespace. I have the AMKO, right, which is also running as a pod in the AVI system namespace itself. Okay, now within this environment, I already have two applications that are running, right, and for which AVI is providing the load balancing. So I will show you that in the GUI later on. And basically, right, what I also wanted to highlight is basically how you go about installing AKO as well as AMKO. So the installation of AKO and AMKO is done using Helm charts, right? The Helm charts will reference YAML file for which will provide the properties, right, for you to run AKO as well as AMKO. So let's take a look at what are the properties, right, that you will provide to actually configure and set up the AKO operator, right, through the Helm chart installation. So this is a YAML file, right, for which will provide the properties for you, right, to run and install AKO within this Kubernetes cluster itself. So as you can see, right, what will be required over here, right, will be things like the cluster name, right? You will provide information about what is the container networking interface plugin. And what is most important over here is that this is the network, right, on which the virtual service will actually reside. Okay, so in this case, right, the RV service engines are deployed in a one-arm mode of operation, right? They are attached to the same pod group, right, as the pool members themselves. So in this case, right, the virtual service network is 172.16.70/24. Okay, and so over here, we'll leave most of the settings at the default value. And you will notice that this is where I specify the RV controller IP address. And this is also where I enter in the credentials, right, to actually log in into the RV controller itself. Okay, so that's the YAML file, right, to actually help deploy the AKO operator itself. And then I will then show you, right, the next YAML file, right, which is to deploy AMKO itself. So again, right, the YAML file to deploy AMKO, right, will only be required on the site that is the GSLB leader. All right, in this case, data center 1, where TKG cluster 1 is actually deployed itself. So within the AMKO values.yaml file, right, you will specify the IP address of the GSLB leader, right, which is the RV controller in data center 1. You specify the controller version, right? You specify the Kubernetes cluster members, all right? And then you will specify the login credentials for the RV controller, right? And over here, right, now we actually have to specify these things like app selector, namespace selector, and so on and so forth. Now, the purpose of this selectors, right, is basically to tell, right, the AMKO is that when you create a deployment, right, within the Kubernetes cluster, right, as long as you label, right, your deployment, right, with this key value pair, which is app, right, colon GSLB, right, you will take it that you will need to run, you want to run GSLB, right, for this deployment, and it will correspondingly create the necessary objects, right, inside the RV deployment for you. Okay. And again, this is basically the cluster information. All right. Now, what is also quite important, right, is this GSLB members GSLB members file, right? So if I do this GSLB members file, right, basically contains all the certificate, right, as well as the key information, right, for the two clusters that I have over here. All right. So this is to basically allow, right, RV, right, to actually log on into the API server, right, to glean the right objects, right, so that it can create the corresponding objects in the RV deployment itself. Okay, so now that you understand that in order to use AMKO, right, as well as AKO, you need to create the corresponding values .yaml file, right, to tell the Helm chart how to go about deploying AKO and AMKO, right. Let's take a look, right, at the GUI itself of the controller. So over here, this is the first RV controller. Okay, and this is the second RV controller at data center 2. Okay, so as you can see, right, I have a couple of services, right, that already have been created. Okay, so this is basically a service, right, that is providing ingress functionality for an application, right, that is local to data center 1. Okay, and similarly, right, for this one, right, it is also providing, right, an ingress functionality, right, for an application that is specific to data center 2 itself, right? It's called app1.dc2.acme.demo, and the next one is called app1.dc1.acme.demo itself. Okay, so now if I'm going to go back into the CLI, right? So let's say I do a get pods-a. Okay, so this deployment over here, right, will be the same as this, will be basically this one, right? This will be the 2 pods, right, that are providing the services for this application itself. Okay, so this is basically that service itself. All right, and so what happens is that if I let me get the name of the deployment. Right, it's called QWAT deployment in the default namespace. Okay, so now inside my MacBook, right, I've actually created host file entries, right, for this app1.dc1.acme 1.dc1.acme.demo as well as app1.dc2.acme.demo, right, pointing to the respective virtual service IP address. So if you look at over here, right, this is the virtual service is having the IP address of 172.16.70.51, right, and this other virtual service is having the IP address of 172.16.70.101. So if I look at the host file on my MacBook, right, I actually have configured the respective A records, right, for these two virtual services itself. Okay, so now if I go to let's say the first app, which is sitting in data center 1 itself. Okay, so let's say I do a HTTPS. All right, so basically, right, I end up on one of the container pods, right, that has been created on data center 1 itself, and you see that the address is 79.97. All right, so if I go back to this dashboard over here, right, and if I expand this one, right, 79.97 is one of these pods, right, that is sitting within data center 1 itself. Okay, now if I then go into app, let's say if we could do a refresh, right, currently it's still on 79.97. Okay, let's say if I go to app 2, app 1, sorry, if I go to this app 1.dc2, okay. Okay, so it brings me to this pod that is running on data center 2 itself. In this case, it's 148.150. So if I go to this data center 2 RV controller, right, I can see that it's bringing me to this pod over here. All right. Okay. So now, this basically demonstrates that, okay, with RV AKO, right, you can actually provide ingress controller functionality. All right, so basically, if you can see over here, right, K8S deployments. This is on cluster 1. Okay, so K8S ingress -a. All right, so this is the ingress. Okay, and it's pointing to app1.dc1.acme.demo. Okay, now in case you're interested, right, in how the YAML file for this deployment actually looks like, right, you can actually see it over here. Okay, so again, this is a deployment, right? I have 2 replica sets. Okay, this is the container name, right? This is the service which is exposed as a cluster IP. Okay, and this is the ingress. Okay, all right, this is the ingress. Okay, so in this case, right, AKO is telling the RV service engine, right, to provide the ingress functionality for this application itself. Okay, so now, so let's say, for example, now I decide to scale this deployment, right? Instead of having 2 replicas, right, I will now have 1, right, for this application that is sitting inside data center 1 itself. Okay, so I'll do a scale. Okay, so if I bring it down to just 1 pod itself, right? So if I do a refresh, right, you will straight away, see that, okay, this pod will actually be marked as it'll be gone, right? Because the AKO operator, right, actually knows that this pod is now gone, right, from the Kubernetes deployment, right, and it's no longer available for load balancing. So you see that now this deployment itself has got 1 out of 1 replica that is available. Okay, so now if I then go back into this app1.dc1, right? Okay, I'll only be redirected to the remaining member of this replica, right? Replica set 79.94, as you can see over here, 79.94. Okay, so now if I scale it back, then, right, let's say I put it back to 2 replicas again. Okay, all right, and then I will check that it has got 2 out of 2 running. Okay, now if I go back to my RV controller over here, right, if I expand on this, you see that straight away, right, it puts the other pod back. All right, it puts the other pod back. Okay, so as you can see, right, this are the 2 pods, right, 79.94 and 79.102, 79.94 and 79.102. Okay, so the same can be done, right, for this application that is running in data center 2 itself. Okay, now let me show you the GSLB functionality. So for the GSLB functionality, right, what I've done is that there is this application over here, right, that is called app2.acme.demo, right, that is being load balanced across both data center 1 and data center 2. So you can see this virtual service right over here in the data center 1 RV controller, right, it is being load balanced to 79.90 and 79.91. And similarly, right, we can see the same app, right, being load balanced in data center 2, app2.acme.demo, right, across two ports over here, 149 and 151. Okay, now this RV controller here, right, is basically the GSLB leader, right? So you can see that it is having this, this FQDN, right, that is being mapped on this RV controller. All right, and then within this pool member itself, right, it is doing round robin, which means to say, right, it is doing round robin, right, between this data center 1 as well as data center 2. Now this 70.55 and 70.105, right, are the IP addresses of the VIPs, right, for this application in DC1 and DC2 itself. So let's take a look. Okay, so this is the not this one. This is the application, right? And you can see that 70.55, right, is the VIP for this application sitting in data center 1. Okay, and similarly, right, if you take a look over here, right, this 70.105 is the VIP for this application sitting in data center 2 itself. Okay, so now basically, right, for this GSLB, right, I actually have a separate Linux client, right, that is configured to use the RV DNS service engines for name resolution. Okay, so you take a look at this cat/etc resolve.config. Right, 70.252 and 70.253, right, these are the IP addresses of the RV DNS service engines. Okay, so if I go back over here, right, this is basically the IP address of the RV service engine. As you can see over here, 70.252 is the DNS service engine in data center 1. All right, and this 70. Sorry, not this one. Okay, and this 70.253, right, is the virtual service that is associated with the RV DNS service in data center 2. So basically, right, this Linux machine down here is using the RV DNS for name resolution, and that's how it does the GSLB. Okay, so now if I'm going to do a curl, right, to let's say the application, right, it's called what is it? It's called app. It's called let's see, it's called app2.acme.demo, right? acme.demo. Okay, so from a client, right, I will first of all do a DNS resolution. Okay, and after my DNS resolution is succeeded, the GSLB controller will direct me either to data center 1 or to data center 2. Okay, so in this case, right, it is directing me to this port with IP address 148.149. Okay, which if you look at here, right, is basically redirecting me to data center 2 over here, right? Okay, so it's basically 148.149, which sits in data center 2 itself. Okay, now if I'm going to do a curl again, right, because the configured algorithm is round robin, right, it will actually throw me into data center 1, right? Look at this, 79.91, right, is the port that I eventually land up on. And if you look at the RV controller 1, 79.91 is actually the data center 1 port itself. Okay, so now, so what happens is that, okay, from this cluster over here, right? Okay, so right now, right, I'm on the TKG cluster 1. Okay, and let me get the deployment. And what I will do is that I will scale down the GSLB deployment in data center 1. Okay, and when that happens, right, I would expect, okay, all the traffic, right, to be redirected only to data center 2. Okay, so I'll do a scale deployment / this is the name of the deployment, right, GSLB core deployment, and I'll set the replicas to 0. Right, so currently, right, it is having 2 ports running, and I will now set it to 0 ports. Okay, so and I'm doing this on data center 1. Okay, So I've scaled down the deployment, and if I do a get deployment over here, you see that there are no pods that are running inside this deployment anymore. So straight away, right, you can see that on the first AVI controller for data center 1, right, it records that this service is now down, okay, right, because there are no more pool members over here, okay. Now, if I go to this GSLB service, right, if I'm not wrong, and click on this, right, I will show that, right, for site 1, right, this is down, okay, this is down, okay. So now what happens is that if I go into my Linux client again, all right, which is over here, okay, let's clear the screen, right, I do a curl, right, for the same application again. So what I would expect this to do is that it will redirect me to the service that is still running on the data center 2 itself. Okay, so as you can see, right, it redirects me to 148.149, right, which is the port address that sits inside data center 2 itself, right? So this is data center 2, okay, and this is where the 148.149 port address actually sits. Okay, now if I do a curl again, right, again it will still end up on data center 2, right, because data center 1, right, is down from the perspective of this application, right, as you can see, right, it lands up on this. Okay, so now if I'm going to bring up data center 1 deployment again, I will scale this deployment back to 2 replicas, right? So I'll bring up the application in data center 1, right? I'll do get deployment. So you see that 2 replicas are running. Okay, so you can see that these are the 2 pods that are running. Okay, and let me check the IP addresses. Right, it's having this IP addresses 79.94 and 79.102. So if I go back to AVI controller 1 again, right, go back to the dashboard, okay, I can see that, okay, right, the pods are up and running again, right? So the AKO pod, right, sitting within the Kubernetes deployment actually sees, right, it watches the API server for events, right, and it updates the AVI controller accordingly. So now if I go back to my Linux client over here, okay, right, I do a curl again, right, for this application, which is spread across 2 data centers, right? I will expect it to load balance, right, between both data center 1 and data center 2. So as you can see, right, this port 79.104, right, belongs to data center 1, okay? All right, and if I'm to do a curl again, right, it should throw me to the port, which is sitting in data center 2. Again, 148.149 sits inside data center 2, okay? So now I will go through an example, right, of how, right, you can actually create an application, right, that spans across both data centers, right, such that the necessary virtual services, right, for GSLB, right, and also for local load balancing are automatically created, right, on the AVI environment itself. Okay, so I have two YAML files that I've prepared right before this, right. So let's take a look at them, right? I will run and create, right, the same application across both data center 1 and data center 2. And what should actually happen is that the AKO and AMKO, which is watching for events on the API server, will detect that, okay, there is a new deployment that is created that needs the GSLB services and that also needs the ingress controller functionality, and it will automatically create this on the AVI environment itself. So let's take a look at this YAML file. So again, as you can see, right, this is deployment, all right? So this is basically the selector, right, app:/GSLB, right, that tells AMQ that, this deployment, right, needs GSLB service. Because remember, right, in the previous, app selector, section, right, of the AMKO YAML file, right, we actually say that, any applications that need GSLB service, right, should be labeled with a key value pair of app:/GSLB. Right. So again, so this port is basically this demo port, right? This using this demo image. So this is the service, right? Again, right? This app:/GSLB label is being applied to this service, which in this case is a cluster IP. right? And in this case, I'm creating an ingress as well and giving it the same label app:/GSLB. So in this case, right, I'm going to call it app3.acme.demo, okay? Right, I'm going to call it app3.acme.demo, okay? So right now I am on cluster number 1, okay? So I will then go ahead and create this application on data center 1, all right? And then I will switch over to the cluster that sits in data center 2, and I'll create the same application again, right? Because this application is supposed to be residing in both data centers, okay? So let's do this. F, name of the file is basically this one. Okay, so I'm going to create this right in the Kubernetes cluster in data center 1. Okay. Okay, so basically you can see that it creates the deployment, right? It creates the cluster IP service and it creates the ingress as well. Okay, so let's do a check. Okay. Okay, so basically, right, this is the name of the deployment that I've created. Okay, so it's got 2 out of 2 replica sets that are already running. Okay, and this is the service that has been created under the same deployment with this cluster IP address. Okay, and this is the ingress that has been created, right? Okay, and it's hosting app3.acme.demo. Okay, so let's go back to the AVI controller on data center 1 to see what's happening over here. So now I am on the user interface of data center 1 AVI controller, all right? So if I look at this, right, basically, I can see that automatically, right, all these objects, right, are being created, okay, by the AVI environment, because like what I mentioned, right, AKO and AMKO watches the Kubernetes environment for events, right? And whenever it sees that there's a need to create, either local traffic management, okay, or GSLB services, right? You will go ahead and do it on the AVI controller itself, okay? So you can see that you have 79.105 and 79.106, right? These are the ports, right, that are part of that service itself. So it's just to verify. Okay, so basically, right, you have this two, right, these 2 ports, right, 79.105 and 79.106, right, that are being created inside this deployment. So take a look at this GSLB service, right? You notice that this GSLB service is down, okay? Now, the reason for this is because of the health check, right, which I need to modify, because this specific application that I am using doesn't like to use HTTP GET, right? Instead, it uses, it doesn't like to use HTTP HEAD, right? It uses HTTP GET instead. So let me save this change, right? And then after that, the GSLB service should come up shortly, okay? Now, while that is actually happening, okay, let me go ahead to create the same application over there in data center 2, okay? So let me switch over to the cluster in data center 2, right? So let's do credentials, my cluster 2. Okay, so I'm going to switch over to the Kubernetes cluster that is sitting inside data center 2. Okay, so just to verify, okay, I have the master as well as the worker node in data center 2 Kubernetes cluster. So what do I have over here? Okay, so I basically have the AKO, right? I don't have the AMKO, like what I mentioned, right? The AMKO is only required on the GSLB leader side itself. Okay, so I don't have that deployment, right? Which was created on the data center 1 side. So I only have this the previous GSLB demo that I showed you, right? And a single application instance demo over here. So again, right, let me go ahead to create the same application over here in data center 2. So the name of the file is basically dc2.yaml file. Again, if you're interested, right, you can take a look at how this looks like. All right, again, I use the app:/GSLB, right, label in order for it to be selected, right, and in order for it to be used for GSLB. And the ingress, right, basically performs the load balancing for this FQDN app3.acme.demo itself. Okay, so let me go and create the relevant objects over here on the second cluster in data center 2. Okay, so it creates the deployment, the service, as well as the ingress. And it's all in the default namespace. So again, you can see that I have 2 out of 2. Okay, get 2 out of 2 ports that are available. Right, service, my service is up and running. All right, and my ingress is up and running also. So let's switch over to the controller here in data center 2 and see what we have over here. So you can see that automatically, right, it creates all these objects, right, in the second data center itself. Okay, so these are the ports 148.157 and 148.158. So if you're interested, you can take a look. Here you get port -8. All right, so you have the IP, right, 157 and 158. 157 and 158, right, which are part of these 2 ports, which are part of this 2 deployment itself. Okay, so now back to over here, the GSLB service, right, should be up and running. Okay, so you can see that it is doing the load balancing, right, for app3.acme.demo. All right, and it's green across both of the sites itself. Okay, so now if I'm to go into the Linux client over here, right? So let's go back into the Linux client. Okay, let me do a curl, all right, to app3.acme.demo. Now again, right, like what I say, right, because the default load balancing algorithm, right, is actually so-called round robin, right, between the pool members themselves, right? So that's why I will expect the traffic to be redirected, right, in a round robin manner between data center 1 and data center 2. Okay, so let me do a curl to this app. Okay, so you can see that it brings me to this port 79.105. Okay, so where is this 79.105 port? So let's take a look over here. So it's not over here in data center 2. Okay, and it's over here in data center 1. Okay, right, so it's over here in data center 1. So if I do a curl again, right, I will expect it to send me over to data center 2, right? So you have 148.158, 148.158, which is in data center 2. Okay, so same thing, right? If I do it a couple of times, right, it will be switching back and forth, right, between data center 1 in this case, right, and also data center 2, right, for the next request. Okay, for the next request. Okay, so now so with that, right, I have come to the end of my demo, and I hope that this has been a useful session for you to see the capabilities, right, in terms of how AVI can provide ingress controller as well as global server load balancing for your applications, right, that are deployed in Kubernetes environment. Okay, thank you for watching.